Independent and dependent events. An independent event is an event or situation where each occurrence does not affect the probability of the other. So two things are happening at once, or back to back. Or three things are happening at once, back to back. It'll be on Google Classroom. So, I mean, for example, flipping a coin and rolling a die. Those are independent of each other. If I flip a coin, does that influence how my die rolls? No, they're totally separate. Drawing a card from the deck and guessing a number between 1 and 100. Do those influence each other? No, they're independent of each other. They don't affect each other. So, when you have multiple events or situations, when there are multiple things happening, not just one, but more than one, when there are multiple things happening, multiply the probabilities. Multiply the probabilities. When there's more than one thing that's happening, flipping a coin and rolling a die, two things are happening. You're going to find the first probability of flipping the coin, and you're going to find the second probability of rolling the die, and you're going to multiply. You want to see how it works? All right, the probability of flipping heads and the probability of rolling an even. No, let's do even, that's fine. The probability of flipping a heads and the probability of rolling an even. They're two things that are independent of each other. What's the probability of flipping a heads? 1, because there's one head out of 2 total chances, right? And what's the probability of rolling an even? How many evens are there? 3 out of how many total numbers? 6, which is 1/2. So I'm going to do 1/2 times 1/2, which is what? 1/4. Remember, in multiplying fractions, numerator times numerator, denominator times denominator, you're done. Let's do another one just to practice. The probability of drawing a club. So that's decks of cards, right? And the probability of a month starts with M. The probability of, if I had a deck of cards, the probability that you'd get a club, and the probability that you would get a month, pick a month, that starts with M? So how many clubs are there?
4.
There's 13, ace through king, out of 52, which is 1/4. There are 4 suits. Those are called suits, right? And 1 suit is club, so 1 out of 4. Or you could count ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. That's 13 out of 52. And a month that starts with M. How many months start with M?
2.
What are they?
March, May.
Good. 2 out of what? 12. 2 out of 12, which is 1/6. So we're going to multiply 1/4 times 1/6. Those are my probabilities. What do you get?
1/24.
1/24.
Is that for what?
What?
Is that it? Like all?
I mean, that's independent probability. If you're doing 2 or more things. So, like, I mean, if there were 3 of them, you'd multiply all 3 together. Pretty easy, right?
Yes.
So let's talk dependent events. And dependent events aren't much harder. The only thing is, instead of events or situations where the occurrence does not affect the others, dependent are events or situations where each occurrence does affect the probability of the other or others. Dependent events are where it changes. It does affect. Flipping a coin and rolling a dice are independent of each other. They do not matter. But when I'm doing bingo, have you ever seen bingo being played? And they have that big cage full of numbers, right? And they spin it around and around and around and around. And a ball comes out and they say the bingo number, B5. What do they do with that B5? They put it to the side. And then they spin and they spin and they spin and they spin. And another one comes out and it says G54. What do they do with that next one? They put it to the side. So if we started with 100 ping pong balls, after I pulled my first ping pong ball out, how many are left? 99. And I spin it, and I take out my second ping pong ball, I read it, and I put it to the side. Did it change again? Right? Dependent. They depend on each other. It's going to change. At first, we started out with 100 ping pong balls. Well, after I took one away, I don't put it back. Now, instead of my denominator being 100, my denominator is now 99. So it's a lot of time dependent events. You're looking for the term. Let's do this. You're looking for the term without replacing. Focus. So here's our example. Let's say you have a bag with 3 red marbles and 2 green marbles. What's the probability of a green Kalia, Riley, Adam, and I forgot the other one. I'll have to look. Leadership training. Who's my fourth one that's going to leadership training? Probability of green, then the probability of red without replacing. Oh no, but you are on the list, aren't you? Give me a second. Probability of green, then the probability of red without replacing. Yeah, John, you were on the list too. Did you turn in your position slip? Oh, then you don't need to go. Library, go there first. All right, what's the probability of a green? How many greens are there? 2 out of how many total? 5, right? 2 out of 5. So I picked my marble. Doesn't matter what color it is. Whoop, throw it over my shoulder. How many reds are there? 3. Out of this time, it's out of 4 because I already picked one. And you say, like, Mrs. Long, how do I know if I put it back or I don't put it back? It's going to tell you you replace it or you don't replace it. So I multiply, and what do you get? 6 out of 20, perfect, which simplifies to 3 out of 10. The closer your fraction is to the number 1, the better the chance. Is this fraction close to 1?
No.
What would be 1 if this was our fraction?
10 out of 10.
10 out of 10, right? Is this close to 1?
No.
Is this close to even? Is it close to 50-50 chance?
Yes.
What's a 50-50 chance?
5.
5 out of 10. So it's a little bit less than equal, right? But could it happen?
Yes.
Yeah. If it can't happen, what would your fraction be?
1 out of 10.
0 out of 10 if it can't happen, right? If this said the probability of green and then the probability of blue, could you pick a blue marble?
No.
Why no?
Because there's no blue marbles.
There's no blue marbles in the bag. It's 3 red and 2 green. So that would be a 0% chance, a 0 out of 10. That's never going to happen.
Wait, so that's a probability of getting green or getting red?
Of getting a green and then picking a red. Because it's dependent. It's the same bag and I'm not putting my old marble back.
It's like wasting money.
Right? The lottery, where they do the spinning numbers.
Yeah.
Dependent probability.
Spinning the numbers.
Dependent versus independent. Do you understand the difference?
Yes.
Which one is without replacing?
Dependent.
Dependent. What changes with dependent?
The denominator.
The denominator. See how that works? Dependent. Denominator. Right?